If you thought it was bad enough that space was an endless black void that will kill you the second you step out into it, well, we have some bad news for you. It gets worse. The further we stare out into the stars, the more we realize that, amazing though it may be, the universe is full of strange mysteries, looming gigantic shapes, and terrifying dangers that would destroy our planet without missing a beat. These are the creepiest things found in space. The galaxies of the universe are spread about everywhere, and some regions of the universe have a much higher volume of galaxies than others. But on the flip side, occasionally the universe has small gaps of galaxies called voids, where there are noticeably fewer galaxies than what is typical in our universe. But if you look out into the Bootes constellation, then you will find an enormous void, a very empty space known simply as the Bootes void. This void is so massive that it's over 250 million light years in diameter and has a volume of 236,000 cubical megaparsecs. A parsec is a measure of distance. You might remember it from the original Star Wars, when Han Solo refers to the Millennium Falcon as, quote, the ship that has made the Kessel Run in less than 12 parsecs, end quote, which made people believe it was a measure of time. But no, it's a distance, about 3.26 light years or 31 trillion kilometers. The Bootes void is so mind-blowingly enormous that it makes up about 0.27% of our visible universe, and yet it only contains just 60 galaxies. To put this into perspective, if our species had evolved within the supervoid, other galaxies wouldn't have been visible until at least the 1960s when advanced telescopes were developed. In fact, it's likely that scientists before this time would have simply assumed our galaxy was the only one in a giant dark and empty space. To give you a comparison, our galaxy, the Milky Way, is part of a huge group of galaxies called the Laniakea supercluster. The Laniakea cluster is about half the size of the Bootes void and contains over 100,000 galaxies. So by comparison, we're in a very crowded area, and that goes to show just how depressingly empty the Bootes void is. The creepiest thing about it, though, is that no one really knows why there's so few galaxies in this region of space. The thing that would undoubtedly pose the biggest threat to mankind if we discovered it's an alien civilization. Sure, they might be friendly, and what would they have against us anyway? But if you think about the probability of all the other interstellar dangers, like black holes and rogue planets passing close enough to kill us, they're all pretty unlikely. But with a sentient and advanced alien race, the chance of them coming after us is much higher than all these other things, because intelligence is not random. So this must have crossed some people's minds when we first discovered the enigma of KIC 8462852. This is a star 454 parsecs away. While observing it, astronomers saw repeated dips in its luminosity. A dip in a star's luminosity is normal. It's how you detect a planet orbiting a star. But a planet the size of Jupiter would barely bring the intensity down by 1%. This dip was a massive 15%, and then 700 days later, there was a flurry of dimming, and it went down as far as 20%. In order to do this, the object causing the dimming must be about half the diameter of the star, so there's no way it could be a planet. Its gravity would be far too large to remain stable. It would collapse under that much weight without the pushback of fusion that stars have. But what if it was some kind of alien megastructure? And if there was a species that could build a ring world almost the size of a sun, well, we'd hardly be able to put up a fight. Why would you build something that big, though? Well, one idea put forward is a thing called the Dyson sphere. You basically encase a star so that you are able to capture a huge percentage of its energy output, rather than just the tiny percentage that reaches your planet. This would be an astonishing amount of energy. To give some perspective, we measure large energy volumes in quads. One quad would be 8 billion barrels of oil. The world uses about 400 quads per year, but 20,000 times that much hits us from the sun. And that's just our one tiny planet. If we could harvest everything that hits the Earth, we'd have way more than we need. But a Dyson sphere does this for the whole star. That is not power we'd want to mess with. After this disturbing discovery, SETI joined the team looking at the data. They began hunting for any electromagnetic signal that might give away a sign of intelligent life. Any artificial signal would be easy to recognize, and although we wouldn't necessarily be able to decode its message, it would be clear it wasn't just natural radiation from some star or a black hole. If we do find a message, let's just hope it's "Hi," not "See you soon." On Earth, you know where you are with ice and fire. Ice is cold and fire is hot. Everyone is on board with that. But the universe is a weird place, and occasionally we come across a planet like Gliese 436b that is either boiling cold or freezing hot. Gliese 436 is a recently discovered ice planet that is about the size of Neptune. While that alone may not be very surprising, what is surprising about Gliese 436b is that it is so close to its parent star that its icy surface is constantly on fire all year round. So, you may be wondering, how could this happen? How could ice, of all things, burn constantly? Well, astronomers have determined that the reason why the icy surface of Gliese 436 never melts, despite the hellish inferno on its surface, is because of gravity. The large mass of the water on Gliese 436b's surface is pulled so strongly towards the center of the planet that the pressure is too high for the water to remain in its liquid state, let alone its gaseous state. This pressure on this planet is thousands of times the highest pressure at the bottom of our deepest ocean. As a result, the gravitational force of Gliese 436b is so strong, the ice covering its surface is physically prevented from evaporating, leaving the planet perpetually enveloped in icy flames. There is no confusion about our next planet, though. It's a little further away, 489 light-years away to be exact, and was discovered in 2009. It's called CoRoT 7b. It's quite unique for its super-fast orbit, racing around its star once every 20 hours, which is so fast that you'd barely have time to finish eating your birthday cake before you had to start baking another. Astronomers can't agree on how heavy this planet is, but it's somewhere between 2 to 8 times the mass of Earth. And what makes it creepy? Well, if you thought burning ice was bad, this little hellball has a maximum surface temperature of 2,600 Celsius, so you could set sail on one of its gigantic oceans of magma. It has a weak atmosphere of sodium, oxygen, and silicon monoxide. It has its own weather, and while a spring shower on Earth may ruin your hair, on CoRoT 7b, it could tear down a city because it rains solid metal. It condenses at an altitude of 10 kilometers, so it's like having clouds full of guns that are waiting to be rained down on the ground. The night side of the planet is probably cooler, but we're not sure exactly how it would be made up, although it's likely there would be a big difference between the two faces of CoRoT 7b. A planet flowing with lava would kill you in an instant, but what about the monsters of the universe that refuse to die? Some stars end up in a binary system, much like the black holes we mentioned earlier, and when one of the stars is a white dwarf, that could result in a type IAX supernova. A white dwarf star is a very dense body of a star that has collapsed. It is no longer burning up its mass, like in the fusion of a regular star. Normally, the energy of the fusion reaction is what keeps stars from collapsing under their own gravity. White dwarfs slowly radiate away their heat until they become black dwarfs, but this process would take longer than the expected lifespan of the universe, so no black dwarfs exist yet. But if you have a binary system of a star and a white dwarf, then the white dwarf can strip away material from the other star until it reaches an unstable mass. And then, without fusion, the only thing that is stopping its collapsing is, to put it very simply, the fact that electrons can't occupy the same space. This is because the more dense matter gets, the more pressure these battling electrons create. This phenomenon is called electron degeneracy pressure. So theoretically, a white dwarf star could steal enough mass from its binary pair and go supernova a second time. Often, this would entirely destroy the star, perhaps just leaving behind a nebula, but we now think you could have a zombie star left behind, not really alive, but still not dead either. Scientists believe they have found a possible example in the SN2012Z system. We know this system went supernova. We'll just have to listen out there for ungodly moans to see if there was a zombie star left behind afterwards. And zombie stars aren't the end of it. We also have to deal with vampires in our universe. We need a binary pair of stars again. And while this sounds like it must be rare, in fact, about half the stars in our galaxy end up in these dancing pairs. Stars generally have a similar evolution, which is only really dependent on their size. We've got good at using this knowledge to work out how old a star is, but we started to come across stars that were burning much hotter than their neighbors, which is where the blue name comes from. Blue things in our universe are hotter, red things are colder. While this seems illogical because of how we use colors for temperature, red light has the longest wavelength, blue the shortest, and a shorter wavelength means higher energy. But stars in one area should form at roughly the same time, since they are the result of a gas cloud converging, so we struggle to understand why there were these younger, hotter stars mixed in with an older group. Now we think they are actually a wolf in sheep's clothing, an old star that has sucked the life out of another star, one from its binary pair, and it has used this new mass to really boost its fusion reaction and get that rosy glow of youth in its cheeks again. Here on Earth, we're probably safe from these vampiric monsters, but it may be worth NASA firing a few tons of garlic up into the sun just to be safe. At the center of every galaxy is a supermassive black hole. But what is really strange is that there are also gigantic black holes that are traveling through the universe this very moment at millions of miles an hour. SID 42 is one of these supermassive black holes. SID 42 in particular was the result of the collision of two galaxies. The black holes at their centers merged to form a supermassive black hole, but this collision also caused a huge emission of gravitational waves, and the newly formed black hole recoiled like a bouncing ball and was hurled outwards from the center of its galaxy. The strange thing about SID 42 is that the amount of energy needed to move a mass this size is vast. As the two black holes come together, they form a binary pair, but they need to dissipate energy in the form of gravitational waves. This is what was finally recorded by the LIGO project, which detected a merging pair of black holes 1.3 billion light years away. The energy they released at their peak was 3.6 times 10 to the 49th power watts, which is more power than all the light from all the stars in the observable universe. As for the recoiling black hole, it's likely to become a shining, displaced quasar until it burns itself out, which would take anywhere from between 10 million to 10 billion years. SID 42 will be so unbelievably bright that it will have 100 times the luminosity of the entire Milky Way. If this rogue supermassive quasar were to pass anywhere near our solar system, that would be game over. Its gigantic mass would be far, far greater than that of the Sun, so all of the planets would be torn out of their orbits and either swallowed into the quasar or flung out into the emptiness of space. And what about the Milky Way? Is our galaxy going to collide in the same way? Yes, it's heading towards the Andromeda Galaxy, but it'll take at least 3 billion years before this happens. Nebulas are massive clouds of dust, often hundreds of light years across. They're made up of various ionized gases, along with hydrogen and helium, but they have very little density. To give you some idea, if you took a volume the size of Earth, it would only have a couple of kilos of mass spread out over all that space. That's less dense than any artificial vacuum mankind has been able to make. So, why are they creepy? It's just a cloud of dust, right? Well, while clouds on Earth might be cute and fluffy, nebulas often form huge and twisted shapes, like something right out of a horror film. The Cygnus Loop Nebula was discovered in 1784 by William Herschel and is the remnant of a supernova. It's sometimes referred to as the space head, since its form resembles a deathly shroud, like the ghostly outline of a face. Next, we have the Hand of God, observed by NASA's Nuclear Spectroscopic Telescope Array. This is a pulsar wind nebula. Pulsar is short for pulsating radio star, which are very dense neutron stars that rotate regularly, giving it a repeated pulse of emissions. The Hand of God is probably the result of a previously massive star that went supernova and collapsed. There's also the twisted shape of the Horsehead Nebula in the constellation of Orion. The Horsehead is also a dark nebula, meaning that it is so dense it blocks the lights from objects behind it. But worst of all is 30 Doradus. It's better known as the Tarantula Nebula, and really, it just looks like a gigantic space spider. While there is nothing inherently disturbing to this nebula, it certainly has formed into a shape that would give many on Earth the chills. We all know about the dangers of asteroids. It's one of the first things that you learn from sci-fi movies, but where a giant asteroid would still need to impact Earth to do any damage, and this is pretty unlikely given the huge expanse of space and how fast everything is moving, there are other larger objects that could disrupt the solar system. Rogue planets hurtle between the stars. They have either been ejected from their own solar system by an impact or the pull of something heavy, or perhaps they just formed far enough away from any stars so they never settled into a particular orbit. So if something the size of Jupiter suddenly appeared near our sun, it could knock everything in our solar system out of alignment, just with its gravitational pull alone, possibly sending Earth off to receive the same fate it had, becoming an orphan lost in the universe. Even smaller scale things like deflecting our moon or pulling Mars into a different orbit, all these things could affect us now that the careful balance of our solar system has been altered. And there are a lot of these wanderers. Some estimates only put it at 2 rogue planets for every star in the Milky Way, but others raise that figure up to 100,000 times more. It's almost like no one actually has any idea how many there really are. For more top lists just like this, be sure to leave a like and subscribe if you haven't already, and don't forget to check out our other lists, and we'll see you all next time.